Hey guys, Carlson here to cover Chapter 5, Population Ecology with you. We'll take some quick Cornell notes and then we'll be applying a lot of these concepts in the classroom to understand them a little bit better. So let's get started with the three important characteristics of a population, which are its geographic distribution, or where that population is located, the density of that population, and then growth rates. So we're going to start off, what is density? It basically is the number of individuals per unit area. For example, I might say 20 people per square mile. And there are some factors that are involved with that. Density independent factors would include things like abiotic factors like weather and natural disasters, where the effect of that factor would not be dependent upon the number of individuals present. Now, density dependent factors are biotic factors that affect the population size, and it is worse the more dense the population is. Some examples would be parasitism, predation, disease, and competition that we'll again get more into in the classroom. All right, some characteristics of how population numbers increase and decrease would be the birth rate or the natality, how often individuals are being born, while the opposite then would be the decrease in the number of individuals through mortality or death rate. We can also have individuals that immigrate in, and then emigration would be individuals leaving. All right, reproductive patterns also affect population sizes. So continuous breeding would be when there is reproduction that occurs many times throughout a lifetime. Most vertebrates are this way. And then there's discrete breeding, where there's only one reproductive event in a lifetime, most often happening with insects and plants. There are some population growth models that will depict the growth of a particular population and or decline, and the first one we're going to look at is logistic growth. It produces an S-shaped curve and occurs when resistance is present, and it has four main phases. The lag phase is a period of slow growth and a small population size. Then we have exponential growth, which is when we start to accelerate in population size. And then there's a small deceleration phase, and this is just slow growth where resistance is starting to pick up, and at that point we have a stable equilibrium. There's little to any growth. Maintenance is basically being done, and we reach something we call carrying capacity. Now, carrying capacity is the maximum amount of individuals the environment can support, and at this point we should have our greatest environmental resistance being applied. Some things that would be applying that resistance would be competition among organisms, predation, parasitism and disease, drought and other climate extremes, and human disturbances. And we will be in class basically pointing out which ones of these are density dependent and which ones are density independent. And we did already, of course, talk about them in the lecture. This is what a S-curve would look like, or logistic growth. So you have your lag phase here. We have our sudden exponential growth, and then we have a deceleration phase where we're slowly kind of holding back on that population levels rising, and then we hit that carrying capacity where we kind of keep a flat line. We're just maintaining that population size. All right, when there are no environmental resistance conditions being in place, so in other words there are no limits, we usually will see exponential growth continue and produce a J-shaped curve. So there are ideal conditions and unlimited resources. And that would of course look like this, exponential growth curve here. Only two phases are present in this one. We have the lag slow growth phase and then the acceleration of growth, which would cease to stop. If it were to begin to occur environmental resistance, it would end up eventually turning into an S-curve. All right, and that is all for your Chapter 5 notes. I'll see you guys next time.